for a positive 3/8 and a positive 2. Well, combining these, I need to like denominators.
Here we go!
Into 8s. In order to that, I need to change that to 8s. 3/8 and 16/8 makes 19/8.
Uh-oh. Lost
So,
my
the expression
pin.
can be simplified to a negative 4x plus 8.
Let's make it hot.
Identify the method used to expand the expression.
Well, when you expand the expression, you want to be using distributive, where you multiply the outside by the inside.
Use the distributive property to identify the equivalent expression.
When you distribute, I mean, since this is like the beginning, let's do like a little quick little mini lesson, mini refresher. But in expanding expressions, we're doing a lot of distribution, if not all. I don't know what methods are going to go through. 5x minus 0.75. And when you distribute, okay, what you do is you just take this outside number, you just multiply by the terms on the inside. So negative 2 times 5x is negative 10x. And then negative 2 times a negative 0.75 is a positive 1.5. See, so that's how we do that right there.
Use the distributive property to find an equivalent expression.
Alright, see, just like last time, what's negative 5 times a positive 3x? So we know we're going to have a negative 15x. And then what's a negative times a negative? It's a positive, so it has to be one of these two. And then a negative 5 times a negative 6 is a positive 30 over 7. So that's the one.
Analyze how one expression was rewritten to form another expression. Were all the steps correct?
Alright, so they did negative 6 times positive 4. You see that kind of down here. With negative 24. Okay, so what they did is they actually went the slower route, which is just, instead of doing the operation, they kind of just rewrote it. So negative 4 and positive, I'm sorry, negative 6 and positive 4 is here. Then there's this mistake, looks like it's right there. Because this is a negative. That should have been a negative. Yeah. Because if they would have distributed everything, it would have been negative 6 times a negative 2 13ths, which would have been a plus 6 times this inside. It wouldn't even have to be positive. So I'm gonna go with that right here. I'm gonna say no. They distributed incorrectly. The negative 6 should have multiplied by the negative 2 over 13 to become negative 6 parentheses negative 12 over 13. I'm sorry. Something like that. Yep. See that? All right there.
Can you identify the equivalent expressions?
Okay. This has a lot of moving parts, so I would actually just distribute it so I can kind of see what's going on. I know we're missing the music. Yeah. Much better. Okay. Alright, we got negative 9 times the quantity, 2 over 3x plus 1. Distribute. Negative 9. And then, what do you see right here? Negative 9 divided by 3 is negative 3 times 2. Notice how I just keep the 2, put it there. Negative 9 times the positive 1 is minus 9. Negative 3 times 2 is negative 6. Minus x, forgot the x, minus 9. So, I see that right here. So I'm going to make sure I mark the negative 6 minus 9. And then I need... See how this will come to positive 9 and this will come to 1? So that's not correct. It has to be this one. So we check here and it has the exact same thing I've written here. Negative 9, 2/3 x, 2/3 x. So I'm going to go with this one, that one. Yay!
Determine whether the expressions are equivalent.
Okay. Again, maybe semi-moving parts, like a little bit. But the best thing to do is just do it. Just do it. Oops. Negative 0.5 times 3x plus 5. Again, distribute. We're going to get negative 1.5 because negatives find positives. And then negative half times 5 is a negative 2.5. Forgot my x. And did they get negative 1.5 minus 2.5? No, they did not. So you just say no. The negative 0.5 should have multiplied by the 5 to get negative 2.5. It's weird when they do that. Use the true property, yes. Yes, if you evaluate the expression, they are not equal. Yeah, we said that, dude. Relax. It was probably looking for like a 0 right here where I put a 0.5.
Simplify the expression.
Yeah, quickly. Again, I got negative 9.2 8x minus 4 plus 0.72 plus 63x. Wow, they just gave you a whole bunch of big one, huh? So, man, we have a lot of calculations to do. They were not friendly. I'll tell you what, we're going to use a test strategy. Why don't we collect the x's first? No, let's just simplify this whole thing and then we'll look at it again. Maybe we can use that fancy strategy next. Okay, so negative 9.2 times 8, 16, 1, 72, 73. Oh. So we're going to get negative 73.6x. Negative, right? Okay, the negative 9.2 times 4 is 8 and 36. So minus, plus, this is a minus times a minus. So this is going to be plus 36.8. What does that mean? Seek status disconnected. Alright, so then what's a positive 0.7 times 2? Well, that is, at least they're making it easy for me, 1.4. Because just the 2 times 7 was 1 decimal point. 2 times 7, 1 decimal point. And then what is 0.7 times 63? I believe that's going to be, nope, going to be 9. So 6.3. So yeah, this has 2 decimal spots. 7 times 42, 44. So 4.41, 21, 2, 42, 44. Yeah, 4.41. So plus 4.41. 1.41x. Now, right here we're going to combine like terms. We've got x and x. And if we notice, this is negative, this is positive. So they're in effect going to work like a subtraction problem. What's 73 minus 4? But it has to be negative. Can't be these. It's got to be one of these two. And then again, if we just kind of loosely, lazily combine these two terms, what's 1.4? This is 2, 1, 8, 3, 38.2. Positive.
Can you identify the equivalent expressions?
Well, this is interesting. Negative 1 and 29. That sort of gives us a hint. But let's use the same strategy. But I'm really interested in what happens here and what happened here. Let's see what happens. They made that a triangle. My 4s look like triangles. Oh man. X plus 7 minus 3 1/2 x minus 5. Alright, so what's okay, what do I see right here? What's 2 divided by 2? What's 4 divided by 2? 3 over 2, right? Because this goes to 1. What is 2 times 7 is 14. Alright, now what's negative 3 times a positive 1/2 x? Well, negative 3 halves x. And I don't know what to do right here. Put little alert symbols. Oh, there should be an x right here. Look at this right here. Positive 3 halves x. Negative 3 halves x. What's a negative 3 times a negative 5? It's a positive 15. But what happens here, folks? If you said 0, you are correct. That is a Cyclops smiley, in case you wouldn't. Alright, now we have a positive 14 and a positive 15. So what's 15 plus 14? 29. Now, does that mean the rest of these are wrong? No, they just weren't done all the way. So let's kind of look at this. Here's a 2, here's a 3/4, here's a plus 7. That's the same thing. So anything with a 2, a 3/4, and a plus 7 on the inside, or say we have the 2 times the 3/4 x and then plus 2 times the 7, that's correct. This matches this is all correct. Now plus negative 3 times a half. So far that's going to be okay. What's a negative times a negative 5 over here? This works out. It's the same problem. Because just notice it's the same thing. All they do is just like break it apart, leave it broken up. Put parentheses and confuse everybody. Now here's a problem. We have a positive 3 times a positive half. No. This mistake right here automatically destroys it, right? It's not the same as this. This is all positive, this has a negative. Okay, now the next one. We can have this plus sign here because there's a negative sign here, so this is okay so far. Negative 3 times a half, that's the same thing that you would do here. And we did here. And then they've got plus a negative 3 times a negative 5. And did we do that earlier? Did we do negative 3 times negative 5? We did. And it's going to come out to positive 15. So, I mean, that looks good, too. Yeah.
Simplify the expression.
Oh, at least they're giving us, like, semi-easy numbers to deal with. I hate when they give us, like, 9.2 and 8. I'm like, why? We're trying to learn here. Can we do it easy first, dude? Alright, just rewriting the problem real quick. 6x plus 8. Trying to squeeze it in here. Okay, so this is a 1.5 times 3. X is a positive. So what we're going to end up with is positive 4.5. I know that looks like you add them, but it's not. It's 1.5 times 3. Half of 3 just happens to be 1.5, so it's just basically 3 1.5s. Oh, that's what it says right there. Okay, x 1.5 times 4 again. What's half of 4? So it becomes 4 plus half of 4. I know these are like little tricks. All right, here we go. We have a 0.25 times 6x. So there's a you know what, I'm gonna not use the tricks. I don't want to confuse anybody, but there's an easier way to multiply these numbers a lot. Just think about fractions if you want to know the tricks. 6 times 5, 30. 6 times 2 is 12 and 15. And then we want to come right back. Did I do that right? I did do that right. Why is it wrong? Oh, there we go. It's not wrong. Alright. Plus 1.5x. Then we have 0.25 times 8. I'll use the trick now. 0.25 is the same thing as a quarter, right? A quarter. And a quarter of 8 is 8 over 4 or 2. Combine like terms. 8, 6x plus 8.
Compare and contrast how you simplify algebraic and numeric expressions.
Compare and contrast expanding and simplifying algebraic expressions with simplifying numeric expressions. For example, compare. Oh, okay. Compare and contrast. Oh, they mean like with variables and without variables. Okay. This is like when you get complicated as a society, young people, when you start using words to describe words that we're trying to learn. Like, we want to be learning about algebra and variables and such, and then we start naming things off and expect the understanding. Well, I hope that we see that in when we solve algebraic expressions, we have to kind of do things backwards. Like, we can't just do what's inside the parentheses, right? We're always taught do what's inside the parentheses first. But in algebra, we can't do that. We've got to kind of take it apart and work backwards to get our answer. Whereas when we have numeric expressions, we don't have to do 3 times 5. We can just do, what's 5 minus 2? It's 3. 3 times 5, 15. So basically, algebraic and numeric expressions involve the same steps. We just work them in different directions depending on what we are doing. What we are doing. Right, whatever. Wow, actually marked me wrong. You're a turd. Alright, next activity. Quiz time, baby. Here we go. We're gonna get this. Have I gotten 100 recently? It's been like 3 lessons. I was about to say they're not gonna even see that. That's how they're gonna get me this time. They're just not gonna give me questions. Alright. Let's get this stuff. Good stuff here. Alright, which expression is equivalent to? Alright. No problemo, man. So here's what I'm gonna do. What's half of 30? It's 15. What's 3/4 of 30? I'm sorry, what's 3/4 of 40? It's 30x. I know my answer has to have 45x. Nope, that is incorrect. I'm gonna write this down because I'm already messing up. Alright, so what we got? We got 30 half x minus 2 plus 40 3/4 y minus 4. What's half of 30? 15x. What's 30 times negative 2? Minus 60. Alright, what's 40 divided by 4, which is 10, and then what's 10 times a 3? That it would be 30y. And then what's a negative 40 times a negative 4? Well, that's a plus 160. Right? Except I messed up. This is a positive. So let's get rid of that. So this is a positive times a negative, so it's a negative. Alright, so let's combine like terms. I see this and this. So 15x, I'm just going to scoot this over. Plus 30y. Because you got to bring the sign with it, right? Now and then we have negative 60 minus 160. Now these are only like terms, so I'm just going to rewrite this 15x plus 30y. What is negative 60 minus 160 more? Both are negative, so we keep the negative, and since the signs are the same, we add them. So once 160 plus 60, 0, 2, 1, it's 2 minus 220. So we're looking at 15x plus 30y minus 220. Whew, they're trying to get me. They can't get me this time. I'm on my grind. Alright, what is the resulting expression? Alright, I love it. I think they start all these tests out like, just do it. I like it. It gets my momentum up. I feel confident. Alright, minus 0.5, negative 2.4, x plus 4. Alright, so then 0.3 times 4. So what's 3 times 4 is 12, right? And then it got one decimal spot, so just put a little decimal there. And then 0.3 times 8, well, what's 3 times 8? 24, right? So just put a decimal there. What's a positive times a negative? You betcha. What's a negative half? What's negative half of a negative 2.4? Well, first of all, negatives times the negatives are positives. And what's half of 2.4? 1.2x. And then what's a negative half of a positive 4? 2. So I'm gonna combine here. So 1.2x plus 1.2x is 2.4x. And then I got a negative 2.4 and a negative 2. I'm gonna combine them to become negative 4.4. So I'm going with 2.4x minus 4.4. Oh, look at that. I love it. This test is acting like Mr. Murray. This is how I would give a test for reals. 150x minus 80y plus 50 minus 50x minus 25y plus 20. Well, okay, so there's a fifth. So we're going to divide every single number by 5 or multiply by a fifth. Same thing. When you multiply by a fraction, you're doing the same division by the number on the bottom. Or flipping it. Doing a reciprocal type of deal. But if I were a cheating man, which, I only do it when it's allowed, I know that all my x terms are going to be correct. It looks like where the difference is the y's and the constants. So, but just to go through it, a fifth of 150, what's 150 divided by 5? Well, that's 30x. So What is 80 divided by 5? Well, what's 40 divided by 5? 8, right? And since this is two 40s, 16, so negative 16y. Not there yet. What's 50 divided by 5? Plus 10. What's 50 divided by 5? Minus 10x. What's negative 25y divided by 5? Negative 5y. And I believe now we see it. And now what's 20 divided by 5? Well, that's plus 4. And there's the second part of our answer. And if we notice 30x minus 10x is 20x. Negative 5 and negative 16 combined to negative 21y. Right? Both negative. Both y's. And then what is a positive 10 plus 4? So we're looking for 20x minus 21y plus 14. Which expression is equivalent to 8x minus 12? So, super cool. Notice how this is all 16 times a half x. That's all going to be 8x. Now, is 16 times negative 4y negative 12y? No way. In fact, we can see that for 16 to get smaller than 16, it's got to be multiplied by a number smaller than 1. Okay. And now, 16 times what is 32? Because right here, 16 times 32. 16 times 2. See that? 16 times 2 is 32. 16 times 32 is definitely not 32. Does that make sense? 2 times 16 is 32. Make sure I got that right. Same. It had to be this. Yeah, then 16 times 2 is 32. Okay. Sorry, just double checking. I want that 100. Whew, at least it tells us to select 2. I gotta read these. This is where I get problems wrong for no reason. Well, I guess that reason is laziness. 7 times a negative 3/4 x minus 3. First of all, there's not really any way to simplify this. So 7 times negative 3 is negative 21 over 4x minus. What's 7 times a negative 3? Negative 21. We're done there. And it looks like they want us to give them mixed numbers. So we've got a mixed number this guy. And if we go backwards, oh, that's where the lesson is, huh? What's 21 divided by 4? Well, it's 5. This one remainder. I'm gonna show you how to do this. I didn't learn this till high school. You guys probably already know this. When you get a remainder, instead of writing remainder r, you actually just write it and then put the denominator underneath it. So this is 5 1/4. So this is negative 5 1/4 minus 21. And look right here. This is the exact same thing we did here. So we're definitely picking this one. And the other one, the only other one with negative 5 1/4 minus 21 is that one. Double check. Negative 5 1/4 minus 21. Check. Checkmate. Again, I hope you're getting the hang of this. What's 8 times a negative 10? Well, it's negative 80x. So it's one of these. Oh, and it could be this. It could be this one, right? 4 times a negative 20. Oop, can't be that one. Could be that one. Negative 4 times a negative 20 is 80x. Ooh, except we're not looking for 80x. We're looking for negative 80x. Yeah, 4 times a negative 20 is negative 80x. Okay, so now what's 8 times... Ooh, see, how about this? Decimals, freaking me out. What's 8 times negative 7? That'd be negative 56, right? Negative 56. Negative 56 is 4 times negative 14. think so. 16, 6, 5, 6. No, it cannot be our friends. Can we? 16 carry the 1, 4, 5, 6. Oh yeah, why did I put 6 here? This is totally not correct. This is 16 carry the 1, 4 times 1 is 4 plus 1 is 5. Negative 56. So we're still good there. And they're gonna make us go to the decimals. So what is 8 times 3.5? So 44, 24, 28. Both are positive, so it's got to be a positive 28y. No. A positive 4 times a positive 7, 28y. Select 2 options, got to go. Alright, another one. Again, 5 times x, 5x. Good. And now we're looking for positive 10y. That's a negative 2. Positive, positive, positive. Cannot be this one because that's a 5, so it's going to be one of these two. And then what is... how do we get to negative 15? Well, we can't multiply 5 times the negative. Oh, we're back up. We're back up. Oh, cool. We are back up, people. I should not play. I should not have my video games open in the background when I'm doing this stuff. Just gonna double check, make sure we're good to go here. Alright, we apparently are still alive. That's good news. Let's finish this out. Alright, where were we? Yes. 5x plus 10x minus 15. Alright, which expression? Double checking. Oops, what did I just press? Alright, we apparently are still alive. Oh, good. Alright. Which expression is equivalent to? So once again, what's negative 3 times 4x? That's a negative 12x. And what's half? What's negative half of 3? That's positive 1.5. Which expression is equivalent to? Wow. Thank you. That was so awesome of you guys to give me such a wonderful, long problem. Alright. So we've got, wow, they're so long. 14x minus 3y plus 28x plus 12.2 minus 5y minus 17.5. Check the answers here. It is possible that we can find the correct answer on the first go, but I really don't think so. So 2 times 14x is 28x. 2 times a negative 3y is negative 6y. 2 times 28x is 56x. 56 plus 28 is 84, so we kind of know it's going to be one of these two. Alright, 2 times 12.2 is 24. 24.4. 2 times a negative 5 is negative 10y. And then 2 times 37 or 17 and a half is going to be minus 35. Good. All right. So we let's go ahead and combine x's. This is going to be 84x. Negative 6y and negative 10y are minus 16y. And we'll notice both of our 84x's have the negative 16y. And then lastly, we're going to combine our oh, now what? Oh, wow. Lastly, we'll combine our 24 and our negative 35. So because one's negative, one's positive, we have to treat them as a subtraction problem. Negative 10 point. Oh, yeah. That's not a 4, that's a 6. So negative 10.6. And this 84 is the only one with negative 10.6. Daniel, expand the expression as shown. Yeah. Oh, that's really wrong. Well, negative 2 times a negative 8x is not that. That should be positive 16. So the first term should be positive, sure. Negative 2 times a negative 4y should be positive, so the second term should be positive, right? What's a negative 2? We have to check. This is like being a teacher, guys. You know, you get someone who's making too many wrong answers, and you have to be like, oh my god, I have to check all these. But if you get them all correct, the teacher's like, they got them all right. So right now I'm gonna do this negative 2 times this this last term that we couldn't do quickly in head, or you know, it's probably better to do it out anyway. And that's a positive, just put a little, don't have to. What do I notice right here? We can simplify these by 2 real quick. And this goes to 1 times 3, and this goes to 2. So we end up with a negative 3 over 2. And then they want mixed numbers, so this means this is 1 and 1/2 negative. And remember, just to get this, we have to divide like I showed you earlier. So yeah, it should have been negative 1/2, not negative 1 1/4. He divided by negative 8 by. He divided negative 8 by 2 instead of multiplying negative 8 by 2. No, because negative 8 divided by negative 2 is 4, and that's not 4. He did not simplify the expression completely. No, it looks completely simplified, just incorrectly. Right? Make sure I answered all of them. Yep. Alright, cross your fingers. Oh Lord, I've achieved my goal.